This is a video recap of the RStudio Heatmap activity. We navigate to the DreamHigh RStudio login and type in the credentials that you obtained over email. This is the RStudio environment. Yours may look different and it may take a little longer for yours to load. On the left side is the area in which we'll work, and on the right side is some information about our data and also our files and a few other tabs we'll use. Let's go to the home directory by clicking on the home icon. And we all have the DreamHigh 2025 folder. And in there is our first week's work, Intro to R, and the subfolder Heatmaps. The .rmd for our markdown are the files that we've been using in class. Let's click on the MT cars heatmap activity. We can minimize the console pane. And this is the R markdown file that contains a combination of text and code and syntax. The first thing we do is go to File and save as a file with a different name so we can keep the original as a reference. So now my file has a new name. In the header information, we can put in our name and change the date if we want. The text here will give you some background into RStudio, which is this environment, and also what R markdown is, which is a syntax. Some examples are given here. So hash tags, hash symbols denote headers in our text. We're going to start with some simple and some more advanced R functions, but the usage is very similar. So an R function has a pretty descriptive name, and it takes arguments in the parentheses. The data set we're using is called mtcars. It comes with R, so it's not something we have to load. We'll go to the code chunk at line 82 and use the function called view to get an overall view of the table. It pops up in a new tab. We see that there are cars as rows and performance features as columns. If we want to learn a little more about this data, we can use the help function. So help takes as an argument data or functions that we want to learn about. We run code chunks by clicking on this green arrow. The help file pops up under a new tab in the lower right, and it gives us information, for example, on what the different columns are. Whenever we do an analysis, we have to prepare our data. We're going to be using the heatmap function, so we'll use help to find out information there. So the help file for heatmap gives us its usage, and you see very many arguments. Right now we're interested in the first argument, and that corresponds to a numeric matrix of the values to be plotted. So heatmap is going to take our data, which is now in numbers in the table, and convert the values to colors so we can more easily see the relationships among cars and performance features. So to do that, to prepare our data, we're going to convert MT cars to a matrix because we need a numeric matrix. As that matrix is the function to do that, and we'll assign the output of this function to a new object called data. And we use the assignment operator, which looks like an arrow. We're assigning the output of this function to the object called data. When we run that chunk, a new piece of information pops up in our environment tab. It tells us that we have an object that's numeric in our coding environment. So to run heatmap, And we use the heat map function and give data as the argument. Okay, so we get this heat map. We can pop it out with the pop out icon so we can get a closer view. We see that the cars are rows and the features are the columns, and the values have been converted to colors. This isn't all that informative because we have two features, horsepower and displacement, that have very high values, and the rest of the features have very low values. If we go back to the empty cars table, we see that that is indeed the case, right? Displacement and horsepower have high values compared to the others. And in R, we want to be able to see relationships among the variables. So we're going to use something called scaling. So the scale function does something called normalizing the features so that we can color them and compare them. So it puts the values on equal footing. Let's run the scale function on our data and save it to a new object called data scaled. We run that and we see a new object pop up in our environment. When we've created the object, let's take a look at it by adding a new code chunk. So in the white space, we put our cursor and we can insert an R code chunk. So the first thing, what we'd like to do is take a look at our new object. Let's just say with a comment what we're going to do at the first few rows of data scaled. And we can use the head function. We run that and we see the values look very different, but they preserve the ordering. For example, for the Mazda RX-4, the displacement now is much lower, minus 0.57. For the Hornet 4, it's 0.22. We'll go back to the table, and for Mazda RX-4, the displacement is 160, and for Hornet 4, it's higher at 258. And that's consistent with what we see here, displacement of minus 0.57 to a displacement of 0.22. So now we're going to run our heat map on the scale data, and it's much more informative. Pop it out. Now we see nice coloring for all of the different performance features, and the heat map function also puts columns and rows that are similar, that tend to have similar patterns together, so we can see their overall features. We have a bunch of cars. These tend to be heavier cars. We see that they have very high values for weight, but low values for miles per gallon. So these are large gas guzzling cars, whereas some of these other smaller sedans like the Honda Civic and the Fiat, they have much higher mileage than these cars. You see the dark colors for mileage for this group and the lighter color here, but they're also a lot lighter. And the horsepower is less. So these are lower performing, but more environmentally friendly cars. So this is a nicer view of our data than what we had with the numbers. We're going to use this type of visualization and analysis with gene expression data later on in this program. So a last thing to do with the data is to color our heat map with a different scheme. And we'll load a package called RColor Brewer of different color palettes. And loading packages is done with the library function. When we run that, we load in the library, but we also can use functions that come with the package. Here we're displaying the palette. We can pop that out as well. The very first line is the palette that comes, is used by Heatmap as the default. It goes from light yellow to dark red or brown. We can change it to any of these. We have to be careful to use the exact formatting of the name. I'm going to use greens. So to change the coloring of your heat map, we add a new argument to the heat map function called call for color. And the argument is of this form, and here between parentheses you put your new color palette. Let's see what that looks like. And I have the same heat map, but now it is graded from light green to dark green. So the final thing we want to do here is to save our report. First we'll save the file, and we'll create a report by knitting our R Markdown file, and it will create an HTML file. We can pop that out as well. And we have this report with very nice formatting. We have a header that is linked to the different sections. If we wanted to see our scaled heat map, you see that we have our text. It preserves our code chunks, the comments, and the code that we use, the output from our commands, and also our visualizations.